Yeah. Anyone else can add some points?
Ma'am,
Ma'am, we understood the structure of an atom.
Yeah. Can anybody tell me like what is the structure of no other than Nayanika? Like can Gangana, Samudrala?
Yes, ma'am. Ma'am, in the center, there's nucleus, which is the mixture of protons and neutrons, and around it there are rings of electrons.
Yeah. Yeah, fine.
Ma'am, we even discussed do liquids conduct electricity?
Yes. Yeah. We discussed that. Then what was the answer? Do liquid conduct electricity?
Ma'am, yes, ma'am. Some liquids like tap water, rainwater, they conduct, but some organic substances like oil, those do not conduct the electricity.
Okay, fine, fine. So we were also talking about this I is equal to Q by T, charges by time, right? That is a formula of current with respect to charges, number of charges and time. Yes, we were talking about the salts and how is it helping in the conduction, everything we were talking, right? Then we spoke about the non-conductive liquids, pure water, distilled water, and why distilled water is not conducting. Can anybody tell me why distilled water is not conducting the electricity?
Ma'am,
Yes,
because lack of ions.
lack of ions. Varshit, can you tell me like why the tap water can conduct electricity? Or else listen here, like I'm giving you a solution, like NaCl. So now tell me like whether the NaCl will conduct or not.
Yes, ma'am, it will conduct.
So why it is like it will conduct?
Ma'am, because in that solution, the electrons are freely movable, like they
Fine.
can pass.
Yeah. So now, so listen here. So I have distilled water. In that I have
Ma'am, your
H2O.
voice is low.
So in that I have H2O molecules. Okay. So why this is not able to conduct the electricity?
Ma'am, because it doesn't have any free ions, and when there is tap water or any other salted water or water with salts present in it, it has free ions
Fine.
for electricity to conduct.
Fine. So everybody know that day we discussed about this. Now my question is, can I convert this distilled water such that H2 plus and O minus will be formed, and then it will become a normal thing, and then I can make them to conduct electricity? Can I make that? Is that possible?
Ma'am, you can add something to it, like any other salt.
Instead of adding some other way, if I don't want to add, I want to just split up this H2 and O to H2 plus and O minus. How can I make that? So is there any way to make that?
No, ma'am, because it's a chemical reaction and you cannot change your chemical reaction.
Fine. Anyone else? Yes, think.
Ma'am, if we want to change it, we have to just add some substance like salt, ma'am. We cannot change it.
Okay. Okay. Fine. So anyone else, like Gautam Krishna, what's your opinion? Maybe.
We can't change, ma'am.
Okay. 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 Fine. So no. It's okay. If I'm asking the question like this, so if I want to make a distilled water as a conductive liquid, so what can I do?
We can add salts, ma'am.
Very good. That's a simple question. Simple answer that first who told the new student, no? Forgot her name. Nayanika told. That is the very first thing Nayanika told. So that is a way. You can add salts, you can add acids also, you can add base also, you can add salt also. Okay. Now we were talking about the circuit formation and the things. Yes. So yeah. So we were talking about this. Hope you remember. So this is a lemon juice. We are testing the conductivity of electricity in the lemon juice of vinegar, right? So will the bulb glow?
Yes, ma'am.
Yes? Okay.
Yes,
In some cases, even if a liquid conduct electricity, the bulb might not glow. This happens because weak current. So there are some cases Like in some cases, even the liquid is going to be a good conductor of electricity. The bulb, so here, see this circuit, the bulb may not glow. What may be the reason for that? Weak current. The current passing through the liquid might be too weak to heat the filament to the bulb enough to make it glow. For example, I can say this bulb may not glow because two things. So first thing, as they said, weak current. So we cannot assure that this amount of lemon juice is enough, or this amount of lemon juice is capable to light the bulb, right? So for example, I can tell, so if I eat this much amount of food, then only I can be very active. No, if I want to eat like some 10 amount of food, for example, 10 amount of food, and you're giving me only 5 or 3 or 2, will that be enough for me to do my work?
No.
No, right? Same concept applies here. So this case, actually, the answer should be like may or may not. You should say like may or may not light, because we are not sure that what is the quantity of this lemon juice and how many ions are present. Because can anybody prove me mathematically this one? So I am telling you, we cannot say when we don't know the amount of liquid, we cannot say. And if we don't know the voltage of the bulb, and if we don't know the amount of ions in the liquid, that I cannot say. This is my theory. I'm giving you a theory. I'm giving you a theory that I cannot say that if I have a bulb attached to the circuit and I am keeping a lemon juice as a, the liquid that is going to be good conductor, I cannot say that it will glow or not. And I want you people to prove this mathematically with the help of formulas or something like that. Can you people do that? Yes?
We can do it, but we don't have a formula.
Okay, that is what I'm asking you. We have it and you know it. So is there any formula that can prove this mathematically? Yeah. Anyone? Yesterday only we learned that formula. I'll give you a hint also.
Q by T, ma'am.
Yeah, exactly. I is equal to Q by T. Because, can anybody elaborate this? Why I'm telling this is the correct fit?
Ma'am, because if we know the number of ions in the voltage of the bulb, then because of the time we can find, ma'am.
Exactly. We know the I is equal to Q by T. Q is what? Number of charges, no? Charges. Basically charges. It will be like NQ also, maybe. But IQ by T is a standard. So Q is number of like charges. So if I know this lemon juice, how much amount of energy, or like if you want to be in a very simple way, if you want to say in a very simple way, if we can know how much amount of energy the lemon juice can produce, or how much amount of ions the lemon juice can produce, such that the bulb will be able to glow. For example, this lemon juice is having good enough of ions, but my voltage of bulb, instead of bulb here, if I can connect AC, will the AC work? AC in the sense air conditioner. Will the air conditioner work?
No, ma'am.
No, because the air conditioner needs high voltage. Because as per the Ohm's law, I don't know if people know the Ohm's law or not. People know?
No, ma'am.
V is equal to I into R. So this is the Ohm's law. Just for proving you people, I'm telling you. V is equal to IR is the Ohm's law. So as per the Ohm's law, voltage is directly proportional to current. Voltage is directly proportional to current. So in this case, if I am increasing the voltage of the substance, before it was a light bulb, small bulb, so it may be some very less volts, so that lemon juice can conduct electricity. But if I'm giving you an air conditioner, if I'm fitting an air conditioner motor in the circuit, it won't be able to work, because the voltage required for that is very high. So by this, like this, you can do many interpretation on the problem that we give. Yes, we can do many interpretations, right? So I can also ask you, if I am increasing the voltage of some specific thing in the circuit, how the current will be affected? It will also increase. Current will also increase if I increase the voltage, because V is directly proportional to I. Yes?
Ma'am, what is the meaning of the R?
R is something resistance. And you people are telling me you have not read about it, so I don't want to touch that. So you have resistance here. See here, resistance. The liquid may conduct electricity, but does not efficiently as metals, causing higher resistance and weaker current. Resistance means, so for example, For example, what can I take? Resistance. Okay. So you have a cold and cough. For example, you're going to medical shop, you're getting some medicine, and that medicine is going to protect you against from the cold and cough, or it is going to reduce the amount of the cold and cough. It is basically acting as a shield for you, resistance for you, right? Resistance. Something like it will fight back for you people, right? Like that, in a circuit, we have, you all know about circuits, I hope. So in a circuit, we have resistor. What this resistor will do, the resistor will, whenever there is a high amount of electricity flowing, or when there is a sudden electrical shift, like high electrical shift, resistance will help the, resistance will cut down the electricity. I mean, it basically act as a shield for the circuit. Yes.
Somewhat like a fuse.
Correct, fuse, exactly. What is the difference between, now comes the fuse into the picture. So I asked this question also. So why fuse and why resistant? Why two different things? Why the world cannot use only one thing? Yeah, anyone can answer?
Ma'am, I have a doubt.
Yeah.
Ma'am, in some cases, even may it happen because of the cells, right, ma'am?
What will happen?
Because of the cells, ma'am, means there is no.
Yeah,
Uh,
you're asking about cells. So this is battery.
yes, ma'am.
Battery is going to be a driving force. Correct. This is the lemon juice and this is the bulb. Yeah. So this is basically we're testing the conduction of electricity, whether the electricity is there or not. Yes. Now see here. Now my one more question I can ask from this diagram. Take that as a homework. We are having a circuit. We have a battery and we have lemon juice. What is the purpose of battery? What is the purpose of battery?
Charging
To
is
give
electricity.
electricity, ma'am.
What?
To
Charging
give
is electricity.
electricity.
What? Anyone?
Powering the circuit,
90.
ma'am.
Or giving electricity, ma'am.
Okay. Then what is the use of a lemon juice here?
Ma'am, the
Ma'am,
lemon juice acts as the wire as well, ma'am. It's not giving the energy. It just has free ions which allow the current to pass through.
That's kind of fair answer. Yeah. Anyone else want to add more point on that point? It's a correct
Ma'am,
answer actually. Yeah.
ma'am, it's a substance which checks that whether it is glowing or not. Means the
Exactly. So
bulb.
here you can see there is no attachment, right? There is no attachment, but instead lemon juice itself an attachment. Correct. Here the circuit is broken in the inside the lemon juice. So the lemon juice itself an point that is going to, act as a connection between the circuit. So that what this with this we can test it whether the lemon juice is a good conductor of electricity or not. Yes.
yes, ma'am.
Everybody is understanding. Varshit understanding.
Yes, ma'am.
Fine. So that is a resistance. So yeah. So I was talking about fuse and resistors. So yes, if we have fuse and if we have resistor, both are doing the same work, then why we need two things, two different things?
Ma'am, fuse will totally stop the circuit, ma'am, but resistor will reduce the current.
Okay, that may be a fair answer. Yeah, that is a part of answer, but that's not a full answer.
Ma'am, fuse helps. Fuse saves the circuit from short circuiting, but the resistor just decreases the amount of current flowing through the circuit, ma'am.
That's again not a complete answer. What is a short circuit, first of all?
Ma'am, it's when the excess amount of current flows
Yeah,
through
yeah. So who
wire
is
It
and
will lead to fire,
it
ma'am.
breaks the circuit.
okay? Who is doing that short circuit actually? Fuse is the one who is doing that short circuit, right?
Okay.
Yes, ma'am.
Can you get it? Nayanika told the right answer, but she told like when something short circuit happens in the circuit, fuse will save or something she told. But my thing is, your fuse is the one who is doing the short circuit. Okay. So short
Okay.
circuit and fused, the color, the electricity fused. It's not a different term. Both are same. So both are right actually. 90% both are right. The resistance in the circuit The resistance in the circuit, if we have resistance in the circuit and fuse in the home appliances, we won't see any resistors attached to in our home circuits because fuse is required. Only one thing is there, resistance. If the current is so high, if the amount of electricity, something happened in the circuit, it cannot protect the circuit. It can measure the resistance, it can do certain things, but not beyond that. It cannot protect the circuit. If it is more, it will destroy this full part of the circuit. We have to replace it with a new circuit. But when it comes to fuse, fuse is acting actually like this, no, connector. This is the fuse. You know what will happen? So this is a circuit. If there is a high voltage or high current coming here, the fuse will melt. As a result of melting, this will, remove the connection between both circuits. So this is actually fuse before melting. Once it melts, it will be like, there will be it will melt. And by this, what we can conclude, it can protect the appliances. For example, an air condition is here and here some bulb is there in the circuit. It cannot protect the appliance, but it can protect the appliance as by, removing the connection. That is the exact usage of fuse. So that is why we are using fuse in the big home. In our home circuits, we are using fuse because they protect the appliances and they protect the circuit. So in future, electrician will come and only fuse will be changed, but in this case whole circuit should be changed. That is a difference. Yes, got it, or it's not clear?
Clear, ma'am.
Everybody
Yes, ma'am.
fine. So this is another tester. So can anybody explain this diagram? Yeah, what is, just explain me the circuit, nothing more. Yeah, Gautam, can you do it? Yes, Rahim, can you do it? Speak. 7th standard people are so active. They will not let me to speak. They will only talk every time. Varshit will know, right?
Yes, ma'am.
Yeah. Then why you are silent, Varshit? Your brother Ashwant will keep on talk to me. You won't let me to talk. I cannot complete the portion also in 7th class. Yeah. Talk. Mount Brata.
Ma'am, no, ma'am. Ma'am, in
Yeah.
this circuit,
Yeah.
they are they are using the magnetic effect of electric current as a tester, ma'am.
Good. Good. Then.
Ma'am, when we pass electricity from the wires, the electric wire becomes electromagnet and the compass needle gets deflected, and this will show that the substance is a conductor or
Yes.
insulator.
Correct. So this experiment you have learnt in your 7th standard. Am I right? The same experiment of matchbox. Twist a copper wire around the matchbox such that if you give the current to the circuit, magnetic field will be created. Have you read that topic?
Yes,
Forgot?
ma'am.
Yes,
So
ma'am.
this, what is this exactly? What is this exactly? Magnetic effect of electric current, right?
Ma'am,
By
it
this
shows
we
that
can,
in which direction the needle deflects.
yes. So direction of the current, the medium will tell you which direction the current is flowing. Yes. So yeah, that is actually, this is that activity. So take about two teaspoons. Where is that diagram? Okay, we can make it, not a problem. Take about 2 teaspoonful of distilled water in a clean and dry plastic or rubber cap of bottle. Take about two teaspoons of distilled water in a clean and dry plastic or rubber of a bottle. Okay, maybe it's a bottle. I'll draw the diagram. If I'm wrong, please tell me. Okay, anywhere. 2 distilled water, maybe. You also get distilled water from a medical store. Use the tester to test whether distilled water conducts electricity or not. Yeah, how will you do this? Can anybody explain me the circuit diagram for the same? Circuit diagram?
Ma'am, so there will be like a bowl of distilled water, 2 tablespoons of distilled water, and
Okay.
then you leave 2 loose wires into that bowl of water and connect it to a light bulb and some batteries.
Okay.
and a battery. And if the bulb lights up, then we get then the distilled water is a conductor, but it will not light up as distilled water is not a conductor. And that's all.
Ma'am,
Fine. Yeah.
we should not connect the teaspoons, ma'am.
Why?
The water, ma'am, distilled water. They're telling the measurement, ma'am. The 2 teaspoons.
Correct. Correct. Thanks for correcting. Nice. So it's basically
Ma'am, when you're
teaspoons.
drawing a cell and a battery,
Battery. It's battery, no? So basically we can, instead of these 2 tablespoons, we can do like a lime juice also. So it will come down here. Exactly like a lime juice. I can connect a bulb. You can replace the tablespoon, right? Am I right? That's not a wrong thing. Bulb we'll give a representation of bulb. This is how the bulb looks. Yeah. Now the circuit is complete.
Yes, ma'am.
What will happen in the circuit now?
And the bulb won't light up because it's
yes,
distilled water.
Very good. So what is the next sentence?
Ma'am,
So
at
what
last,
do you find?
Common salt.
ma'am,
What?
at last,
We
at
should
last,
add NaCl, ma'am.
So you're adding the pinch of common salt in this,
ma'am, if you
right?
add pinch of common salt, the bulb will go.
Will glow. Okay. Can anybody tell me the equation for this? Chemical equation, chemical reaction, how it will react H2O. So distilled water basically consists of H2O molecules.
And
Then
H2O plus NaCl becomes H2O plus NaCl because it's not a chemical reaction, and we can separate the H2O and the NaCl.
so now what will be the resultant?
It'll just be salt water, ma'am.
Exactly. So here H2 is plus H2Cl will not form. It will actually, yeah, it will form actually. That may become HCl. And O and Na, I don't know. They will be like precipitate. So they want NaO,
Ma'am,
sodium
it won't
oxide.
become
They
like
can
that
form, it can
unless
become, no?
I don't think so, ma'am, because it's just a reaction where, and also NaCl is soluble in water, so it can mix with the water and make a solution.
Solution. Fine, fine, fine. I got the point. Yes, that may also be the case. Even I don't know what will happen. I am just interpreting you. Fine. So you find this anyway. I am still curious if some reaction can happen or not. You find it. Okay? Yeah, good. So can anybody answer? I think everyone can answer this question. Yeah. Lemon juice, compass needle shows deflection. So they are basically taking this experiment. And just think this. Yeah. Can anybody answer? Second one, vinegar.
Yes, ma'am.
Yes,
Yeah.
ma'am.
Yeah. Start.
Ma'am,
Yes,
it's
ma'am.
yes, yes,
Yes.
yes, and then no, no, no. I think.
Okay. Everybody got the
Yes,
same
ma'am.
answer?
Yes, ma'am.
The solution. Yeah.
Mhm.
So lemon juice is yes, they are a good conductor. Vinegar is also good conductor. So yeah, the needle will show the deflection. Tap water is also vegetable oil will not. It's a poor conductor, right? Oil will
Yes,
not do
ma'am.
any. It will not show any deflection. Milk will say, and honey will not, and distilled water will not. Alcohol will not. Now my question is, why it's no, 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 and no?
Ma'am, lack of ions.
Lack of ions. Okay,
Ma'am, they're
that is
organic.
correct.
Ma'am, they're organic, ma'am.
Okay, fine, fine.
But ma'am, milk is also organic. So then how is it a good conductor?
Yeah, because water is there in that milk, no?
Okay.
What presence of water is there in the milk? If you go and see, if we will see, I think my screen is visible, no?
Yes.
Yeah, see here. Milk is approximately 87% of water, actually. Can you get?
Yes, ma'am.
So obviously it will be a good conductor. So alcohol, what happens to alcohol? Alcohol does not have free ions. Alcohol chemical formula. So it is basically C2H5OH or CH3CH2OS. It's an ethanol carbon compound. It's carbon hydrogen oxygen element. So we'll have why. Can anybody tell why alcohol don't do that conduction?
Ma'am, because of no free ions.
So because the bonding inside the alcohol molecule is strong enough to prevent the water molecules from breaking the connection, it does not ionize in the water. So basically, if it you people, I hope you people know that what is a reaction basically called as. So when you have a free ion, so that will react with the next side. Like the reaction, the basic reaction means you have a free ion. And the free when you have a free ion, you have the good conduction of electricity. But for that, you need to break the bonds of the chemical things. For example, in alcohol, they are telling that the bonds between the hydrogen and carbon is very strong, such that we cannot break the bond with the help of electricity. So I want to ask one more important question. So what is this diagram suggest? Like, what is this diagram is actually doing? The current is coming from the battery. It is trying to break the bonds between the components in the lemon juice, right? That is how you get the free ions, right? How you will get the free ions? They will break with the help of electricity. They will break the bonds, maybe the hydrogen oxygen bonds in the lemon juice, so that
Yes.
H plus and O minus ions will be formed, right?
Yes, ma'am.
Yes.
Am I clear? Why?
Yes, sir.
See, I have not
Yes,
asked
ma'am.
this question. What is the role of battery now? It is giving you the electricity, but why the electricity is needed? Because lemon juice will not have free ions. So with the help of electricity, we can make the free ions. We can break the bonds and we can make free ions. Same way here they are trying to say. In the alcohol, honey or vegetable oil, the bond they have with the compounds is very, very, very thick, so that with the help of electricity, you cannot break that bond. Yes?
Yes.
Ma'am,
Baking soda.
what is the pass more amount of electricity?
It won't, because the bond, it also depends on how others components are present also. For example, they are fully connected bonds and they don't have any other people to react with. Or they may be basically like wood, non-reactive substance. So in that case, whatever electricity, how much ever you give, they won't conduct.
Yes, ma'am.
Like a wood. They are basically not, not good, not a friend with electricity, you can say like that.
Okay,
And
ma'am.
also you have one more concept called, I think, polar molecules and non-polar molecules. That also talks about the conductivity. Polar and non-polar liquids molecules you have. So that also talks about the conductivity. You need to learn that also to exactly classify something is good or poor conductor, like that. Yeah. So see here, lemon juice and vinegar contains acid. So this is the explanation actually. Lemon juice and vinegar contains acid that ionize and conduct electricity well. So contains dissolved minerals and ions, making it a good conductor. Tap water. Vegetable oil lacks free ions, so they do not conduct electricity. Milk contains ions and electrolytes, obviously electrolytes, so it's a good conductor. Distilled water, we know that already, typically lacks ions, poor conductor. And salt water, high ion content, excellent conductor. Baking soda dissociates into ion, a good conductor. Yeah?
Ma'am,
Yeah?
is there difference in the conduction between the cold water and the hot water?
I don't think so. There will be no conduction difference.
Okay, ma'am.
Just the temperature of the liquid, because we know what is the formula for conduction. For if you want to know such things, always go with the formula, mathematical proofs. That will give you exact picture. So if I'm asking, what you're asking, your heatness, like whether if the cold water or hot water will have any impact on conductivity. So conductivity means like maybe V is equal to IR, you can take the electricity. Electricity is nowhere dependent on temperature, right?
Ma'am.
Ma'am, I have a doubt.
Yeah.
Ma'am, is there a formula like how can we know whether this is a good conductor or bad conductor?
Yeah, that is what I was telling you. You have to learn. You have to learn about the chemical bond structure of lemon juice, chemical bonding structure of alcohol, chemical bonding structure of honey, and then you have to interpret which one is good and which one is not. So that comes by practice, and that comes by more learning chemistry. You should know. You have to have a background in chemistry also. 1 second. Yeah. See, even we would not know. When you learn more and more, we will be knowing, right? Now, how you people know that wood is not a good conductor of electricity? Did someone come and teach you practically? They broke the wood and shown you something? No, they told you, and you tested it with yourself, right? You people all know when rubber is not good conductor, wood is not good conductor. How you people came to know? Because of the consistent practice, or like you people are having that in day-to-day life. That's why you came to know, right? So that we
Yes, ma'am.
cannot go every day and learn about the compounds, every day go and learn about the bonds, what one, which one will conduct, will not. We can't do that. Practically impossible. When you do more laboratory things, we can do. So these are some questions. So I think we can go to this question. Can anybody solve the first question? These are all your 6th, 7th standard portions only. You can solve. Can anybody solve the first question and tell the answer to me?
Ma'am, the answer is 3 volts, ma'am. I think.
Ma'am, 12 by 4, 3.
12 by 4, 3. Fine. Second one?
Ma'am, electricity can break the bonds of distilled water and vegetable oil.
Yes, ma'am. And there's not enough free ions to
Ma'am,
allow
lack of free
electricity
ions,
to work.
ma'am. Lack of free ions.
Lack of free ions. Very good. Yeah. Third one?
Ma'am, it
Yeah,
will
third
increase.
one.
The
Ma'am,
strength
it
of
will
the
increase,
electromagnet
ma'am.
will increase.
It will increase. So how you're telling me it will increase?
Increase, ma'am.
When you increase the
Ma'am,
number of coils in an
ma'am,
electromagnet,
when
the
increase the
number
number
of
of coils, the
the
more
amount
number of
of strength
electricity will
increases.
pass through the nail, ma'am.
One by one. Plus, first one, the boy, somebody was telling, Nayanika, you please wait, okay? Let that
Okay.
Ma'am,
guy, yeah.
ma'am, if the more number of coils, then the more number of electricity will pass, ma'am.
How can I believe that? How will I know that? I want to have some proof, right? To believe that. What is the proof? So you can basically tell like this. So when there is a matchbox and I am rounding the coil, so you have one formula, but I don't want to discuss that now. When number of coil increases, area of that coil is actually increasing, right? So it's basically a wire, straight wire we are making into a coil. So when I increase the area, so it may increase the current. So how can I say like that? So if I can build a certain amount of structure of house in one ground, if I'm increasing my ground, like I am increasing the one ground into 2 grounds and 3 grounds, I can build big bungalows, right? So ground is directly proportional to the amount of buildings that you are building. Correct?
Yes,
Width
ma'am.
of the building, you can say. So you can say like that. So that's a normal interpretation. So if I increase the area of the wire, so obviously that will increase the current. It's a logic representation. Fine. Yeah, then Nayanika, you want to add some points?
No, ma'am, you said my points.
Fine. Okay. Answer these questions. These are just one word answers. Yeah.
Ma'am, wire and batteries, ma'am.
Batteries.
Ma'am, wire batteries bulb.
Your batteries, okay.
Ma'am, switch's role is to off and on the switch or open and close the switch for easy accessibility.
Ma'am, wood and aluminum.
Okay. Okay. Yeah. Conductors and insulators. Okay, fine. Fourth one. Yes, Varshit Kumar, answer. Fourth one.
Volts, ma'am.
Poles. Rahim, answer the fifth, sixth, and seventh. Rahim, are you in the call? Charantej, answer the fifth one.
Ma'am, resistance means it does not allow the flow of current, ma'am.
Okay, when it goes higher. Correct, correct.
Yes, ma'am.
So, who else? Okay, fine. Yeah, Samudrala, can you answer sixth one?
Ma'am, it's Ohm's law, ma'am. I don't know.
Okay, so it's basically, anyone know?
Ma'am, can I?
Yeah.
Ma'am, Ohm's law is V is equals to IR, ma'am. Means Ohm's law is volts is equals to current and the resistance. Is proportional to the current and the resistance.
Yeah, we spoke that just now. So you please make a note of that. V is equal to IR. Okay, so
Okay,
Ohm's
ma'am.
law. And Varshit, tell me the answer for seventh one.
Ma'am, the purpose of fuse is to stop the flow of excess amount of current.
And then why we have to stop?
Ma'am, if we don't stop the 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 device or anything may get harmed or it may burn off.
Okay, that's correct. So the eighth one, can anybody answer?
Ma'am, we should not means touch the that substance with wet hands.
Fine.
Ma'am, it is safe to wear rubber. Ma'am, it is safe to wear rubber equipment, ma'am.
Correct, correct, correct.
Don't
Ma'am,
come
when we
close.
are handling with any bulbs or tube lights, we should off the main switch first.
Correct. Ninth one, anybody?
Ma'am, an electrical bulb works when the filament uh, heats up very much due to the flow of current, similar to a fuse wire, and creates the light, ma'am. That's why the glass around the filament bulb will be very hot because the bulb will glow due to the heat passing through the bulb.
Fine. That's it. So yeah, that's all for today. We will meet in the next class with the new topic. Yes.
Okay, ma'am.
Bye, ma'am. Thank you, ma'am.
Bye, ma'am.
Thank you, ma'am.